It's May 5th, 2025, back here at Boardwalk Hall, and the subject today is swell shades and swell boxes and expression and all that kind of stuff. So if there's one thing this organ has a lot of, it's swell shades. I'm standing here in front of the solo great division, or great solo division, depending on which stop tab you use, with all the swell shades behind me. Nice shot, see the reflection back there. Now, when you're trying to keep sound in a box, which is what swell shades and swell boxes do, you got to remember that there's two ways to do it. You can reflect the sound back in to the box, or you can absorb it. Swell shades are not meant to absorb sound, they're meant to reflect the sound back into the box and keep it there. If you absorbed it, it would knock off all the high frequencies, and when you open the shades, it would change the sound greatly and in a bad way, and it just wouldn't work. So we don't think of it that way. We think of reflecting the sound and keeping it contained with reflection, basically. So keeping that in mind, what did the senator say about the swell shades in the organ? Well, let's refer to the book. From the contract, paragraph 11. We don't need to go through the numbers of the boxes, blah, blah, blah. The swell boxes, which is to say the overall enclosure, shall be suitably framed, and the walls thereof shall be constructed either of wood paneling or other approved material of a total thickness of not less than 3 inches. So whatever the walls are, of course, I mean, these are, and the back wall is the back wall of the building, so that doesn't matter, and the framing between certainly meets that spec. The swell shades shall not be less than 2 1/4 inches thick to cover the entire front of the swell boxes, which is what this is, with such additional shades upon the side or top as the architect may direct. That didn't end up being necessary. Okay, now let's go on to paragraph 12. All shades shall be actuated by individual motors, remember that, and shall be graduated in size so that those first openings shall be of comparatively small size, while those last openings shall be of large size, preventing the minimum of obstruction to the egress of sound. All shades shall close tightly, be equipped with proper felting, be mounted upon suitable bearings, and equipped with a recoil mechanism to prevent slamming when the shades are closed suddenly. Their construction, the construction of the swell boxes and their operation must be such as to provide a dampening of the total volume of sound enclosed at least 50%. The contractor will be held responsible for the results obtained. Okay, that's it. That's all that Emerson Richards said in the contract, which ended up being accepted for the organ. So remember that. 2 1/4 inches thick, and reduce the sound by 50%. That's basically, yep. So what ended up happening? Well, here we have shades, and these are kind of famous and infamous in the organ world. These are, this is one from another division that's been taken out for repair. This is one of the typical shades, okay? This is aluminum, front and back, and it is hollow. You can see through it, right? So there's nothing inside there. And this is it. This is one of the original shades with no modification. Now, I have a little ruler here, and if I measure this here, it's only about 1 1/4 inches thick. It is not 2 1/4 inches thick. There is this little lip that they formed into the aluminum on both sides. Maybe if you add in that little lip, it counts, but I think that's kind of iffy. Now, remember what I said. You can reflect sound or you can absorb it. If we're looking at this shade, I just can't help. See how flimsy this is? This isn't going to do much reflecting or absorbing, really, because this aluminum sheet is only, I don't know, less than 1/16 of an inch thick, and it's barely rigidified with anything in between. There is a spacer here, and there's one here, and there's one here, and there's one here, and the the aluminum is nailed onto the pieces of wood in the center here. This physically just isn't going to do much absorbing or reflecting. Now you might think, okay, well there's this airspace here. Yeah, but there's a gap here, and when the shades close, there's still enough room there that the sound can go through. Now I know why he did this, and this is mentioned in the book, having the shades like this so that when they open 90 degrees, the sound can go through here and here and here and here, as opposed to being blocked by the width of the shade. But the fact is, in the real world, that just doesn't matter that much. It doesn't block the sound that much. So several measures have been taken to improve these, but this is only one version of the aluminum shade. We're not going to go around and look at all the different kinds of shade construction that I found anyway in the organ, starting with brass chorus. I'm here inside the brass chorus division, which obviously has not been restored. And this is the most interesting set of swell shades in the organ, I think. Remember, this was one of the very first divisions to come online in 1929, and this was played from a temporary console. Now I'm going to step down on these stairs here toward the shades. Ooh, almost lost my balance there. These shades are not like any others in the entire organ, and call me crazy, but I don't think that this is pipe organ material at all. I think these are industrial louvers of some sort, because look at the frame. The frame is made of steel, just formed steel, and these bearings and everything, it just looks so heavy and not organ-like. I don't think that these, I don't think that this is actually built for pipe organ use. I think these are some sort of, as I say, some sort of louvers, and they were originally, I mean, the trace that's connecting all the swell shades is made of steel. And of course it's a double gang. And this was originally operated by a Whiffle tree motor on the floor, and they're all connected together. And they're very difficult to move because stuff is just blocking it down below there. But this set of shades is unlike any other in the organ. And I think, I'm not sure what material this is, but it's only the thickness of the metal. I know that's kind of hard to see, but it's only metal thickness. I mean, there's no sandwich of material back there at all. So this is a completely unique set of shades in the organ, and the very first ones that went in, I believe. So now we can go see aluminum shade variation number 1. Okay, now I've moved over to string 2, which is the next chamber. I mean, they sort of share this right front chamber, and this has a set of the sort of standard aluminum shades, but this is what's called Derailium. It's this stuff, as Stephen Smith said, it has a texture kind of between aluminum and cardboard, and I don't know what it is, but they made a lot of shades out of it. You can see it has this specific kind of texture, and they used it front and back end on the inside. And there you can see the inside of the shade. And you can look right through it, and they put a strip of the material on the inside like that, I guess for extra rigidity. Didn't do a whole lot, but oh well. That's the way it is. And here we have an unrestored original shade motor, but we'll come back to that. So this is the sort of like the first variation on aluminum shades besides the shiny ones, and now we'll see a different variation. And now this is the great solo orchestral division, which I was standing in front of in the intro. And from the back, you can see that they have added plywood to the aluminum shades. And it's kind of nice to walk in, and when you turn the corner and you look, you see all this beautiful orange shellacked wood. It looks marvelous and sounds even better because I climb up here. See, these are the aluminum shades, which can still be seen through. Of course, I can't move them enough. There. You can see it still has the original way that the sound could get through, but instead of just having the aluminum, there's a nice heavy piece of finished birch plywood on there. And that reflects the sound very effectively and makes these swell shades so much more effective than they were originally. And yet they are somewhat heavier, but it doesn't matter as far as response time. They open and close super fast, and they're great. Much, much more effective than what was originally installed. But if you wanted to, you could take all the wood off and have it back the way it was originally. I don't think anybody's going to do that, but you could. So now let's take a look at the wood swell shades in the organ, part 2. Now, up here in the swell choir division and in the swell division, you have swell shades which were originally built by Midmer-Losh. And they seem to fulfill the requirements of the contract, because if they open up, you look at that thickness there. Let's see if I can get my hand in there. Well, I can't hold it open and do that and measure at the same time, but that's about 2 inches thick. And they're made of wood and are very effective. And both the swell and swell choir have these original wooden shades, which, as far as I know, are the only ones in the entire organ that were originally wood to begin with. But there are some other wooden ones which outdo even these, but they're back on the other side of the organ. Okay, last stop down here in the solo division. Now remember, the actual solo division of this organ contains the other 100-inch pressure stop, the big tuba, tuba maxima or whatever, that would be up there. That chest is out for rebuilding right now, which is why you can see all the way to the ceiling. You can see the swell shade assemblies up there. Now, because of the special requirements of this particular box, that it has such high pressure and powerful stops in it, it was decided to have entirely new swell shades made. You hear Brant back there voicing pipes. These were built by Patrick Murphy, and they are very thick. They're almost 3 inches thick. To be able to enclose 100 inches of pressure, it was decided to go the extra mile and just have entirely new shades made. The originals are in storage. They haven't been discarded or anything, of course. But if you can imagine those thin aluminum shades trying to hold back 100 inches, and the 50-inch pressure bugle is also in here. So those are, to my knowledge, all the different kinds of material used for the swell shades. But now, how do you get the shades to move? All right, so this kind of odd looking shot. I'm here in string division number 1 over in the left chamber. And on this assembly, we have what is the closest to an original set of the Midmer-Losh swell shade motors as they were originally built. This is the closest that they come to being original in this organ, because others have been modified and stuff, which it's always been for the better, as you'll see. But this is, as I say, as close to what the organ originally had. And so you have individual motors which pull, they inflate to close. So when the organ is turned off, they're open. And notice that these swell shades have not had any plywood applied or anything. They're original. Now, There were a couple of outstanding problems with the system that Midmer-Losh had originally, which would explain why some of these were replaced at various times. And one of them is that if you notice, when I pull on this, I'm pulling on the, well, it's hard to see on the video there, but the pneumatics are square, okay? And I'm pulling on the top of it to pull it open, okay? It's hinged at the bottom. Originally, it was not hinged. This was a square pneumatic with no hinge in it. So it would just sag, and it would try to pull straight back, even though it makes more sense to have it hinged like this because you get more power out of the pneumatic that way. They weren't. They had no hinge in them. They were just a square, like a big book pneumatic. Well, no, not a book pneumatic, just a square flat pneumatic that was that big, and they would sag and they wouldn't pull right. I mean, I guess they sort of worked, but not as well as when you hinge them for efficiency. Now, the other thing that was a big problem, which I saw when I first started working here, which I couldn't believe, is that you remember that the sander called for he called it a recoil mechanism to keep the swell shades from slamming when you close them fast. So in other words, you open it up and, you know, it's not, you're not hearing anything there, even though I can pull it really fast. Well, Midmer-Losh did incorporate a system, a recoil system, which this set of shades has sort of what's left of one, and I'll pick the camera up here. It may be a little bit hard. No, okay, it's not hard to see. Let me turn the viewfinder around here. Okay, you see that there's a block right here. Let me see if I can get the light better. Okay, there's a block right here. Okay, and it has some felt on it that my finger's pointing at, and when the swell shade closes, it hits the felt, okay? That was redone to have the felt on there. Originally, there was a pneumatic on the end here, a little book pneumatic, about, I don't know, 2 inches square, with a hinge that stayed inflated all the time with static pressure from the inside. So all these, every shade front, you know, this one and then the one on the side here, had a pneumatic that was completely inflated all the time with chest pressure. Those things, when they blew out, would create a huge, incredibly noisy wind leak of air just gushing out. It was a terrible design. I mean, it did sort of work to dampen the shades, but there are far better ways to do that, which have been incorporated in the rebuilds. This just has the felt there, which works fine. And maybe someday they'll do something with that, but that's not important. But see, they all have these blocks. It's kind of hard to see. There you go. That's. Let me get my head out of the way here. Hard to maneuver the camera and do this at the same time. But there you can see one of the camera's blocking its own light. But anyway, that's the point. Those pneumatics would just blow out and create these huge gushing wind leaks, and then the swell shades would slam shut. And it wasn't a very good situation. So anyway, so that's the first version. This is the most original one of this style of swell shade motor. Now we'll look at a couple others. Okay, now I'm in the Swell main chamber. I'm down on level 3, I guess. Now the Swell shades were originally moved with Midmer-Losh individual motors, like we just saw, and then somewhere early on, those were removed and replaced with one motor ganged up to run them all, and then that was taken out and replaced with these motors, which were built by Gary Phillips. And so this is sort of like a completely different take on the individual motors, but they work very nicely, and you'll see that there's a hinged pneumatic there. It's hinged at the back, and when you let it go, it doesn't slam, it just goes like that. They're very nice the way they work, and that's what this division has had for many years now and is quite successful. You can see one motor works 2 shades in most cases. They're sort of ganged up like that. So you have the original Midmer-Losh style, then you have Gary Phillips and what he did, and I think the ones in the Swell choir on the next chamber over, those are also, I think those were built by Gary Phillips. But then you have the Midmer-Losh ones that are even more modified. We'll take a look at that. So then back here on the solo side, where I showed you these nice new shades by Patrick Murphy, we have the ultimate evolution of the Midmer-Losh system, where they use the original frames and most of the original parts, but these have, if you look there, there's an adjustment screw, and here, these screw holes are where the original bumper pneumatic used to be. These shade motors have been fitted with CNC machined Delrin pieces with check valves in them so that the opening and closing rates can be independently adjusted. And this is, I don't know if this is the input or output side, opening or closing, but they can be adjusted from the outside and with a perfectly smooth action. And they added these pieces to pull on the twill tape more evenly. And they added the weights to have them respond more quickly, since these shades are a lot heavier. Remember, these are the ones that are almost 3 inches thick. It makes the whole thing work faster, but because of all the internal damping, it's even quieter. So this is kind of like the ultimate evolutionary step as it goes skyward on up into the next chamber. So those are the individual motors. Now there are also what we call Whiffle tree motors working other parts of the organ. I'll show you that. All right, so I've moved over to the enclosed choir division, and there you can see that beautiful, I forget if that's saxophone or trumpet, whatever that is, voice number 190. Yeah, that's right, the high pressure reeds have gone back in since I was here last time. Nice. But this division has 3 what we call swell fronts. So there's one, and there's the second one, right in front of the chamber door, and there's a third one over there. Now, you'll notice that there are no individual motors on here, even though the shells look like they should have them. That's because they originally did have individual motors. And by the way, these have had the plywood added to the aluminum. They just painted it black instead of the orange shellac. But these are moved by what are called Whiffle tree swell motors, which are so named because internally they look like a March tournament basketball diagram turned on its side, or a family tree or something, where you have a set of pneumatics on the top inside of the mechanism, and then it goes through a series of chains and levers and comes out with one output. So every time you move one pneumatic, it moves the one output a little bit. So each one of these, oh, and by the way, I'll note here that this originally also had individual shades, individual motors for the shades, and then early on it was converted to one motor that ran all 3 of these swell fronts, one 8-stage motor. And the linkages that did it were quite the contraption. But anyway, underneath here, you can see there is one of the Whiffle tree motors with the linkage going up, and there's one further back there. There's one for each swell front, and there's the last one. And they like to point out, and it is pretty cool, that one of these motors is the original Midmer-Losh swell shade motor that worked the swell division. One of them is a spare Midmer-Losh swell shade motor, and the last one, I believe that motor back there, is by E.M. Skinner. So you have a pretty good pedigree of the swell shade motors in this division. They also did something pretty cool, where through the electronics in the organ, they have it arranged so that, and I don't know exactly what order it goes in from left to right, but as you open the swell pedal, one stage opens there, then one stage opens here, and then one stage opens on that set, and then it goes back, that a second stage opens there, and so on and so on and so on. So in effect, you have 24 stages, not 8, which is pretty cool. So that's all for this video, the motors and the materials that the swell shades are made from. I'm going to call this part 1. I will do a part 2 when the organ is available to play, which it isn't right now for me, demonstrating how you can use the shades and all the fun things you can do at the console with them. So for that, stay tuned.